Okay, so if you recall, the first type of compounds we did were called what type of compounds? Ooh. Binary ionic compounds, right? Okay, and binary meant just two elements. Ionic means they have a charge, right? What happens how do they get that charge? You guys remember going back to the end of last semester? How do they get the charge? The electrons? Yeah. So they have to either steal electrons or have their electrons stolen, right? If they get stolen, they become positive. If they do the stealing, they become negative, right? Because stealing's bad. That makes sense? All right. And then the second type we did were the ternary ionic, which contain the polyatomic ions, right? They always contain a polyatomic ion. All right. So we had ionic bonding. What was the other type of bonding we learned right before Christmas? Covalent. And what happens in covalent bonding? They share electrons. All right. So that's the ones we're going to learn to do today. Because they don't have charges, we can't use the charges to figure out what the compounds are going to be, okay? So what we're going to learn today is, bring it in here, molecular binary compounds. Molecular binary compounds. So in your notes, this section is, or binary molecular, because we did binary ionic. So you can do it either way, molecular binary or binary molecular compounds. So what's binary mean again?
Two.
Just two. Yeah, not more. So remember, ternary means three or more. Binary means just two. All right? If you go on into chemistry and you get into organic and stuff, molecular compounds can be huge. I mean, like, have hundreds of atoms in them. And the rules for naming that's what organic chemistry is all about. And it gets very confusing, especially at this point. We're not really going to get into organic chemistry in this class. If you like this stuff, take a college class and then major in something that will require it, okay? But for right now, we're just going to look at molecular binary compounds, all right? And again, these are compounds that have two non-metals. Remember the ones over on the right side of the staircase. They're going to be two non-metals. They're going to share their electrons, and they're going to be covalently bonded. All right, Oh. All right. Two nonmetals sharing electrons, covalently bonded. All right. Why is that important? There could be a question where it says, oh, what kind of bonds would be, or which of these compounds would have covalent bonds, or which of these would have ionic? Well, you need to be able to figure that out, and you should pretty easily by going, oh, it's two nonmetals, that's probably covalent, right? And remember, if it contains a polyatomic ion, it actually has both. It's covalently bonded inside the polyatomic and then ionically bonded together. Oh yeah. All right. Now, of the types of naming and stuff like that, this is the easiest. I actually started with the harder ones. This one is so easy. It's so easy that sometimes people mess it up because they're like, wait, those other ones we had to do math. There's no math involved with this. It's really nice. You're going to like it. All right? I promise. All right? You just have to not get confused by it. All right? So, in molecular binary compounds, we're going to use prefixes. I don't know what a prefix is. Prefixes to tell exactly how many of each element is in the compound. Oh, a little English. What's a prefix? Yeah, it's a modifier that comes before the word, right? Like you have runs and you have reruns, right? Or aerobic and anaerobic. An would be your prefix, right? Okay? So they are so simple. All right, now, there's a really key thing if we're using this method. And how do you know? There'll be a prefix on the second element. Well, if it's two nonmetals, they should be using the prefix method. All right? Once in a while, they do this weird thing They started doing it and they've kind of gotten away from it, where they were using a fake charge on the first one and using a Roman numeral. You don't see that very often anymore, okay? But if it's two nonmetals and there's a prefix on the second one for sure, all right? If there's a prefix on the second one, then the first one doesn't have to have a prefix if there's only one of them. So if there's a prefix on the second, but no prefix on the first, then there's only one of the first. Okay? Does that make sense? It's kind of a weird deal. But the second element must always have a prefix. So I'm going to scroll up just a little bit. Scroll. All right. What's that? Yeah, that means there's only one of the first. If there's only a prefix on the second element in the compound, that means there's only one of the first one, okay? So let's use green, all right? Okay, so carbon dioxide, okay? So we've got the prefix. So let's figure out what elements we have. We have carbon, and we have, what's dioxide gonna be? Cover up our prefix. So what element's that gonna be? Oxide, which would be oxygen, all right? Okay, remember they still do the thing where they change the suffix to IDE, all right? If we look at our periodic table, all right, here's carbon and here's oxygen. Are they nonmetals? Yeah, they're on the left side of the staircase, right? Left and above, okay? So they're both nonmetals, so we're using the prefix method, all right? Do you guys know this one, what the prefix di is? 2, all right? So what it's telling me is there is 2 oxygen. Is there a prefix on the first one? No, so that's it, CO2. There was no math involved in that problem. That's kind of handy dandy, isn't it? Especially if you don't like math. I like math. I like things that come out with right answers and wrong answers. You know what I'm saying? Oh, okay. All right, so that's just what I've got there typed out so you can see it a little better. All right, you guys have it? Can we go to the next thing? How do I know the prefixes? Well, let's learn them puppies, shall we? All right. Guys, these are something, a lot of these you're going to know, but if you don't, I would like you to memorize these so it would not have to be something you look up, all right? So, the prefix for 1 is, not on the screen because I didn't scroll right. The prefix for 1 is mono. Mono, all right? So put this in your notes. If you need to, make flashcards, but we're going to use them quite a bit, so hopefully you'll, and we're only going to worry about up to 10. Can there be more than 10? Probably, but we're only going to worry up to 10. All right? What's the prefix for 2? We just did it. Di. Oh, that's not nice. Oops. Di. All right? What's the prefix for 3? Tri. Like the song by Kobe Calais. Except spelt different. All right. What's the prefix for 4? Yeah, it's in this case it's not quad. Okay, and that's a good guess. That really is. All right. Have you guys ever played that? It's a video game where it's got the 4 boxes and you try to get rows of 4. What's that called? Tetris. It comes from tetra. That's why everything is 4 boxes. It's just in different shapes and stuff. All right, so tetra. All right. For number 5, think of a big building.
Sky.
For 5?
Wait.
A big building in Washington, D.C. Penta. The Pentagon. You want to know a fun fact about the Pentagon? And it may still be, it was the largest office building by square footage in the world. And it may still be, I'm not sure. It is actually, so it's Pentagon, it's got 5 sides. It's actually got 5 rings, and every ring is 5 stories tall. Isn't that crazy?
How many square feet was it?
A million something. I mean, millions. I mean, it was huge. I'd have to look it up, but I just remember I saw the whole thing about it. It was actually from concept to completion in like 2 or 3 years.
That's crazy.
Yeah, yeah. Back without computers and stuff. Shocking. Sometimes it works. All right, 6. Think of geometry. No. It's from geometry. What's a 6-sided shape called? Hexa. Yeah, hexagon. No, that's okay. 7. Some of you may have saw it when it flashed up. Oh, I'm not doing a very good job of covering. All right, 8. What's 8? Octa. Maybe you already have seen this. What's 9? Did you guys see it? Some people call their grandma this. Nana or Nona. I think it's pronounced Nana, but if you want to say Nona, I don't get upset. All right, and then 10. Think of 10 years. Deca. That's it. That's all you're going to have to know. All right? You want to do one more example?
Yeah.
It's another example off that worksheet that we did not do. All right, oops, let's flip it around like this. Okay, so this one has prefixes on both elements. So, diphosphorus, which element's that going to be? Diphosphorus is going to be which element? Phosphorus, what's the symbol for phosphorus? P. Pentoxide, what element's that going to be? What's oxide? Oxygen, which is O. All right? So how many phosphorus? 2. How many oxygen? 5. Isn't that way easy? They just tell you what to write. I love it. Okay? So if you don't know all those prefixes, and I don't expect you to have known all of them right away, make sure you do know them. We're going to do some practice with it, and then we're going to go from there. Okay, so real quick, the front side is all molecular binary formulas. The back side is a bunch of practice with the ionic ones. Boom. It is in grid form. So let me explain a couple things about this before I pass it out. For those of you working at home, if you don't have a printer, do this side. If you do have a printer, go ahead and do this side. If not, just wait. You can do it when you come back. All right? On this side, the way this works, first of all, if it just has a negative or a positive, that's a 1. So that's plus 1. If you're not sure, look it up on the periodic table or your polyatomic ion sheet. All right? The ones that are more than 1, they do indicate that. But what you're going to do, did you guys ever do multiplication tables like this? Yeah, it's just like that. What you're going to do is you're going to take the positive thing and the negative thing, balance their charges like we've been doing, and put it here, right? Positive, negative, put it here. Remember, we always write the positive thing first. Always write the positive thing first. So, I don't care if you show it worked out in the box or not. So let's look at this one I've got worked out here. So Mg is plus 2, right? Going down here, PO4 is negative 3. They meet here. So I went and showed it, plus 2 and negative 3. What do they both go into? 6, all right? What's 6 divided by 2? 3. What's 6 divided by 3? 2, but it's a polyatomic, so I put it in parentheses and put the 2 on the outside. Are you with me? If you get stuck, let me know. I like this sheet a lot. It gives you a lot of practice, but it also gets you a lot of practice with similar charges, so you start to see the pattern, so you don't have to sit there and think about the math every time. All right, I'm going to pass those out, and we can get started. Give me just a second to stop the video and